This is the Calculus Pre-Lecture Series. I'm Caitlin Murphy, and this podcast is on types of convergence. There are two types of convergence, absolute convergence and conditional convergence. So, given a convergent series, we'll say the series A sub n, we will consider a related series where we take the absolute value of each of the summands. We'll call this the sum of the absolute values. Okay? And this new related series is going to help us determine the kind of convergence for the original series. So we have two definitions here. A series, the series A sub n, is absolutely convergent if the related series is convergent. Otherwise, a series, sum of A sub n, is conditionally convergent if the original series was convergent, but the related series diverges. So, given a convergent series A sub n, it's important to remember that this series can either be absolutely convergent or conditionally convergent. But not both. So if we have a convergent series, we're going to find the series of the absolute values, and then that will determine either absolute convergence or conditional convergence of our original series. So this tree shows a little bit of a visual breakdown of this process. So we start at the top with our original series, the series A sub n. If this series diverges, then we just say it diverges and we're done. On the other hand, if it converges, we're then interested in knowing if it absolutely converges or conditionally converges. So the next step right here would be to find that related series by taking the absolute value of each of the sums. So we get the series of absolute values. If our new series converges by some convergence test, then we say that our original series is absolutely convergent. If our new series does not converge, diverges, then we say that our original series conditionally converges. So one strategy that's common to save time that we use is to start right here at this branch. So if we're handed an original series, we'll just begin by finding the series of the absolute values and test that for convergence or divergence. And if that converges, then you just end up right here in this leaf of the tree that our original series is absolutely convergent and you're done with the process. Now we can consider this table, which is just another visualization of the same process. So here in the left column we have our original series, if it's convergent or divergent. In the second column we have the related series, if it's convergent and divergent. In the third column we have the conclusion about the original series. Be careful and note that this is about the original series, not the new related one. And then on the right hand side we'll have some examples that we can work. So in the first row we show that if our related series is convergent, no matter what happens, our original series is absolutely convergent. And we're done. In the second column, or in the second row, if the original series converges, but the related series diverges, then our conclusion is that the original series conditionally converges. And finally, in the third row, if our original series diverges, then our conclusion about the original series is that it diverges, and we're done. So really quick, let's look at these examples on the right. So for our first example, we have the series -1 to the n over n squared. Okay. This we could show converges by the alternating series test. But if we consider the related series, where we take the absolute value of each of the sums, we end up with the series 1 over n squared, which converges by the p-test. Thus, we fall into this first row situation, and we say that our original series is absolutely convergent. For our second example, we have the sum -1 to the n over n. So we can show that this, our original series, converges by alternating series test as well. Can be shown. But the related series, if we take the absolute value, is just our harmonic series, which diverges by the p-test. So our conclusion is that the original series, -1 to the n over n, is conditionally convergent. And finally, our last series, the sum of -1 to the n over n, we can show that this diverges by the nth term test. So our final conclusion would just be diverges.